We're going to look at a little bit about SAN and DAS in the 21st century. DAS in a shared storage configuration, different ways to address the user from a user perspective, the user point of view, and some key takeaways. So we've got about 29 minutes of our flight. So let's look a little bit from a historical perspective about storage. In 2005, there was very different applications, requirements, and designs. Fiber channel was pretty mature by 2005. SANs were very well understood. They were pretty much proprietary. It wasn't really, connect any fiber channel component to your SAN and it's going to work, right? There wasn't a lot of interoperability, but there was a lot of great solutions being built around from the same vendors. And it was easy to tell, what storage application was for what. There wasn't a whole lot of diversity. In 2010, there's a lot of pressure on DAS to share content outside the server. Obviously, virtualization is very pervasive. It could be VMware, it could be Xen, it could be KVM. There could be a lot of different ways to get virtualization. But there was a lot of requirements to share that storage, to have that storage be mobile across servers. And so there's a lot of development and innovation around storage. And SAN architecture really is more converging into specialized servers running storage apps. It's not the requirement now to use SAN as your only data center backend. So where are we going in the future? Well, there's a lot of innovation around this. So there could be everything converged together in a virtualized environment where you've got virtualization at the top layer, all the way down into virtualization middleware, all the way down to abstraction and virtualization at the hardware level with MRILV. So there's universal platforms configured for specific tasks over shared storage. So your storage is becoming more and more and more converged and shared and transparent to the end user and centrally managed. So I'm going to look at 3 different ways to look at DAS from a shared storage perspective and some trade-offs. The first is what we call TSV, or total total storage virtualization. This requires no changes to your current architecture, and what it does is it takes all of the storage down at the low end. It could be SANs, it could be islands of DAS storage, it could be iSCSI storage, and you install a virtualized middleware, and all of that storage then becomes centrally manageable and available as just large pools of storage to the LAN or to your clients. And there's a lot of positives to that and some negatives. Another way is with SAS topologies. So this is shared SAS, and you probably see a little bit about it out there. There's a concept of SAS switches now, and there's also integrated SAS switch technology on the back end of servers, which allows you to share SAS. This requires changes to SAS architecture on within the server. Or you could bring that outside the server, and there's changes to the way you connect SAS. A third way is using IOV. IOV is a hardware abstraction of virtualization, to where resources, actual controllers within servers, become virtualized and shared amongst resources. And that's another way to share DAS, is with a single controller in all of the servers actually look at that controller as its own resource. A little bit further into total storage virtualization, again, I said that you could take SANs, islands of DAS, iSCSI, whatever your block storage is, and abstract that through middleware to where it's centrally managed. So there's no need to modify existing servers. It is what it is. You connect this middleware in the middle of it, and this could be, I believe, Hadoop would be a good example of that. Some of the negatives is performance is not optimal. So if you're looking for an infrastructure where you're going to get optimal performance, then this is not for you. It's limited reliability, accessibility, serviceability. Because it's so distributed and so disparate in its architecture, it's more difficult to service. And it's got a higher cost per gigabyte because of the SAN, the cost per gigabyte of SANs, the cost per gigabyte of fabrics, of different fabrics. Hey, I remember you from in shared storage, this is a concept of SAS switches or fabrics up from SAS, and this could be, again, integrated outside the box or integrated inside the box. This is a very high end. It's very optimized. It shares, the great performance attributes of serial attached SCSI. There's a lot of embeddedness to that, so there's not a lot of extra software you need to install. It's very centrally managed. Performance is optimized. Reliability, accessibility, serviceability is very centralized and very universal, so it's very easy to integrate, but requires servers to be modified to maximize it. So if you're going to be integrating SAS expanders inside boxes or inside the back of boxes to be used as SAS switches or a fabric, that requires modifications to servers. So there is some cost prohibitiveness to this type of architecture. But it does allow you to share all the storage using SAS zoning. So you do get that benefit of SAS zoning across the fabric. I/O virtualization is the ability to use an MIOV switch or an IOV switch in order to abstract the hardware to the resources above it, to the physical servers. So you get the best of all worlds, but this is a very complex topology to architect. It is the best of class in I/O services because it's down closer to the silicon. But there's a major change in server infrastructure and management to get to that. So this is really a great solution, looking for its problem. Because you could solve it in many different ways. So this is going to happen, and you'll see a lot of this in server blade architectures and technologies. From the user point of view, there's no right or wrong problem, right? No right or wrong solution, because from the user, it's all transparent. It's all abstracted. All of them are viable and address the same problem in different ways. So you really have to look at, is cost the main driver? Is performance the main driver? And some markets are bigger than others in order to get economies of scale and develop these different and disparate types of solutions. But user education is very important to this. So in order for any of these architectures to be pervasive and ubiquitous, you need a lot of user education, a lot of draw from the end in order for the middle to develop these architectures.